The elements, a visual exploration of every atom in the universe. Now is the day that we finally get to actually talk about the elements. It's only been a few minutes since I finished recording the Zero video, but same thing here. Let's start off with hydrogen. Hydrogen. It's the most abundant element in the entire universe, mainly because it's only created with this. A proton and an electron and an orbital field right there. Stars shine because they are full of hydrogen. Our sun was created by fusing hydrogen together like this. Sorry if this sounds very weird. But even with all that fusion, we were able to create stars and eventually nebulas. Stars shine because of that, and light happens inside space because of that. It's the most abundant element in space, and it's the most abundant element in the entire universe. Also not the most abundant element on Earth. Our own sun itself actually consumes, according to the book, 600 million tons of hydrogen per second. And then they convert it into like 596 million tons of helium by fusing them all together. So, and what do you think about it? 600 million tons of hydrogen per second. And even that at night, when we can't even see the sun. So where did all the other 4 million tons per second go? Well, it's converted into energy according to Einstein's theory of relativity, E equals mc squared, as you know. There's a lot about it too. The sun's ferocious consumption of hydrogen is really, really great. It's also the lightest element as well as the lightest gas. It's lighter even than helium, and both of them light up. It was much cheaper than helium, and so it was used in the Zeppelins until we realized what happened to the first Zeppelin, the Hindenburg. It blew up. But then again, I don't think the people died because of hydrogen. I think they died because of falling. One downside of hydrogen, though, it's very flammable, so it's really easy to light up. Even a little bit of heat, by little bit, I mean like little bit compared to what happening in the sun, will be able to light it up. However, they were able to use helium, which is not as cost-effective as hydrogen, but it's still kind of expensive. Hydrogen's atomic weight is 10.8111. It has a density of 2.46, and its atomic radius is 87 picometers. This is its crystal structure. I myself still don't understand it. And here is its wavelength. Firstly, this red part here, it's the electron filing order. Go Google that up. Then we have the atomic emission spectrum and the state of matter, which there is, like how much of the state of matter there is in the entire world. This is solid, this is liquid, this is gas. This is pretty much the only part that everyone will understand. And then we have helium, the second lightest element in the world and the second lightest gas in the world. It's named after the Greek god of the sun, Helios, because it kind of hints towards the dark lines in the spectrum of the sunlight. Like the fusing of hydrogen creates those dark lines and those dark spots, eventually creating those solar flares. It might seem a paradox that an element that's like common enough to fill party balloons was actually the first element to be discovered in space. The reason is that the helium is one of the noble gases, and well, so named that because they do not interact with anything else. They remain aloof and they're basically lone wolves. As a replacement for hydrogen in airships, so helium was used because, well, luckily it doesn't blow up. Secondly, it's just cost effective compared to the other floating gases. The main problem is that it's a lot more expensive than hydrogen, and so it provides somewhat less lift. And anyone will want to go on a ride on a balloon that just flies to like 100 meters, or would you rather go to 150 meters? Who cares? The helium that we use today is extracted from natural gas, mainly because, well, it's deposited there. When the natural gas itself decays a little bit, it turns into helium. Mostly nowadays, you just use it for helium balloons, as the thing you're seeing right now. Here's its atomic weight, 4.002602, density is 0.001785. There's its atomic structure, its atomic radius is 31 picometers, and its crystal structure is like that. And then, well, there's only gas form of it. There's no solid form of it. A little note, the atomic number of the element is usually half of the atomic weight. And then we have lithium. Lithium itself, it's very soft and it's also a very light metal. It's also the first solid that we are introduced to. It's so light that it actually floats on water before it explodes. And this is the only feat that is only matched by another metal, and that metal is sodium. While it's floating on the water, it will release some of its hydrogen gas, and It will do it at a steady moderate pace, not enough to explode at a bang. But then again, after sodium, it starts exploding a bang, bang, bang. Everything else will start exploding. It's also used in fireworks, mainly because of that hydrogen gas thingy. We use this a lot. It's very abundant in the world, and it's very light. It's also very energy useful, and we use it in lithium batteries. Lithium-ion batteries are very portable, also they are not useful in long-term charging, so mostly you'll find them in laptops, iPhones, and even the device that you're using to watch this now. It's also soft enough to cut with hand shears, which will leave marks on it. Here's his atomic weight, 6.941, density 0.505, atomic radius of 167 picometers, and a crystal structure of a cube. Mostly found in gas form, but you will always find it in a solid or liquid form. Alright, next up we have beryllium. Beryllium itself is, let's say, a little bit different from lithium. It's a light metal, also it's 3.5 times dense as lithium. It's still significantly less dense than aluminum, and because of that, it's still also soft too. Lithium, it's soft, and it's low melting and reactive, while as beryllium is strong, melts at really high temperatures, and notably resistant to corrosion. The opposite of lithium, basically. And those properties combined with the cost and poisonous nature, yes, beryllium is poisonous, you can account for all the beryllium that's carved out of it. Mainly though, we use them in several things. Sometimes you coat them with certain types of things to make sure that they work better. It also has very fancy procedures as well too. It's transparent and it's non-existent, like X-rays can't see them, so it's used as X-ray windows, like the windows that you use to shoot the X-rays through. And for some reason, people think the high-tech stuff will make golf a bit better, so they coat golf clubs with beryllium copper. And that doesn't really work, so it requires skill. The atomic weight is 9.012, density 1.84, radius of 112 picometers. And finally, we have boron. Boron, it's not boring, although the name suggests it is. Boron, when you add them with nitrogen, you get crystals like the one you're seeing right now. And those crystals are as hard as diamond, and they're more expensive than diamond as well too. In their crystal form, they are just about as hard as diamond, are unscratchable except by diamond, obviously. And their definitions of hard are pretty good too, so that's why they're used in nuts and bolts a lot. And if you go ahead and you add them into certain chemical reactions, you can create silly putty. And boron carbon engine sabotage was always used. Boron was used in car sabotages, by the way. Boric acid was also recommended from eye washing to end poison in the olden days, but I don't think that's a good idea nowadays. You just don't want to put any random chemical inside your eyes. It's never gonna work out well. And boron carbide also has one of the hardest known substances. It even has a kind of a secret agent application. Granules of it is poured into like the oil fill holes of an internal combustion engine, and that will destroy the engine, which is why there's a boron carbide engine sabotage. And that's it. That is the first 5 elements of the periodic table. Next time, I'll talk to you guys about elements number 6 to 10. Next time, we'll start off with the carbon of life. Most people call it the element of life. So I hope you guys enjoyed this episode. I hope to see you guys soon. Until next time, ciao, peace. Bye-bye.